Hi, I'm Jalisha, Assistant Professor, Department of Mathematics, St. Joseph's College of Arts and Science for Women, Hosur. Today we are going to see the normal forms in discrete mathematics. Let's move into the topic. So before getting into the topic, disjunctive normal form and conjunctive normal form, we should be clear about what is min term and what is max term. So if we are considering two sets with its intersection property, here intersection place will gives the minimum space. Whereas if you need to know the union, so union size will be the join of those two, which will be the maximum space. So this minimum space here it is represented as min term, that is intersection. For intersection only here we are using the cap symbol. So cap always represents the min term, or otherwise it is called as meet. That is the intersection space, meeting space. Whereas the union is otherwise called as the max term, or else it can be called as the sum value. In other words, it can be explained as joining two sets to get the bigger one. So join. Min term are called as products, otherwise called as meet, and max terms are called as a sum value and otherwise called as join. So this is the general set concept. The same based on the same concept here, min terms and max terms are expressed. Now, before moving into the concept of min terms, for two variables, if p and q are there in the question, means it is a known thing that four rows will be there for solving. So we are giving those four values here. So min term means we are going to apply it for cap, and max term means we are going to apply it for cup. So if both the values are true means we can specify p and q as such with the join of cap. That is, we are going to connect p and q using cap. If suppose q is false means in that connective term we need to represent q as negation q, and suppose for p value false is given means negation p. So for cap the min terms we are going to represent here. In the first row both are true. We are not going to apply the definition of cap. Here we are going to represent the min term. So both are true means P and Q in as such. So P, Q connected with cap. What about the second row? Q is false. So you can write this min term as P cap negation Q. Likewise, third one, P is false. So we'll get negation P cap Q. Last one, both are false. Negation P cap, negation Q. Likewise, cup means we are going to join the terms by cup symbol. But if both are true means PQ will be as such. If Q is false means again P cap, negation Q. What about the next? Negation P, cup Q, because in the third row P is false and in the last row both the terms are false. So you'll get negation P cup, negation Q. Hence, the third column is called as the min term column and the fourth one is called as the max term column. So this we have explained it for two variables. If suppose we are going to use three variables means it's already known we'll have 8 rows. So based on the 8 rows, suppose in the first row PQR, three terms are true means we can note the min term value as P cap Q cap R. And in between suppose only Q is false, P and R is true means you can represent the min term as negation P cap negation Q cap R. And in the same process, we can construct for the cup also. That is the max terms. So that is explained in the first two lines of the slide. So now we can come into the definition of disjunctive normal form and conjunctive normal form. Disjunctive normal form is defined to be as the sum of products. So here sum is the common symbol. It is represented by cup. Cap is the bracket term. It should be represented by cap. So how we can explain here means, if suppose for the based on the disjunctive normal application, if we are applying equivalence formulas, and the final step we are having negation P and Q term, and another one is P Q. So if it is going to be the disjunctive normal form means the bracket terms should be a min term. So it should be connected with cap, and the common connected with be a max. So how we can explain this in the word format means, cup means sum. So sum of product. This can be expressed as sum of product. So this is the definition for disjunctive normal form. Whereas conjunctive normal form means product of sum. So common symbol should be cap, and the bracket symbol should be cup. So here I have given the example for conjunctive normal form, that is cup in the brackets and cap in the common term. So this way is called as the product of product of sums, and this is the sum of products. Let's move into the problems. So here the question is, obtain the disjunctive normal form of negation P cup negation Q tends to, that is conditional negation P cap R. So we need to get the disjunctive normal form. So we are going to apply the equivalence formula which we are having. Using that, and the final step we should have disjunctive means cup should be common. So obviously the bracket terms are with cap. So let's take the given statement, negation P cup negation Q tends to negation P cap R. See, tends to is here. So already I've explained, if tends to is there means we can change the tends to into cup. If so, then the tends to's first term should be off with the negation. So here negation is missing. So here you'll have negation. So we have changed this tends to into cup. For that, for the first term, we applied negation here. So you'll get negation of negation P cup negation Q cup negation P cap R. Now this can be solved by using the De Morgan's law, because here a negation is common in front of a sub bracket. So this negation is taken inside this bracket. So while we are applying here for each element, this cup will be changed into cap. So negation of negation P, you'll get P. Cup will be changed into cap because of De Morgan's property. Again in the second term, 2 times negation is applied means by cancellation law, you'll get Q. Cup, the last term will be as such, because there is no cup or tends to or two symbols to apply the distributive or De Morgan's law. So directly we are keeping the second bracket as such. Now looking into this bracket, cup is the common term and cap is the minimum term which is present inside the bracket. So such form is called as a DNF form. So we obtain the DNF for the given proportion formula. Next problem is to get the CNF value. What is CNF? Conjunctive normal form. So here the given question is negation P cup, negation of P cup Q, biconditional P cap Q. So here we are having a formula. If R biconditional yes is there means it is actually this is equivalent to R tends to S and S tends to R. Biconditionals actual meaning is if R then S. Similarly, if S then R. So that is symbolically represented as its equivalent form. So applying that equivalent form. So here instead of R we are having negation of P cap Q, and instead of S we are having P cap Q. So substituting in this formula, for R negation of P cap Q and S P cap Q, we get this line. Now we are going to simplify this line. So how we are going to simplify is, negation is here cancelled. How means this tends to is changed into cup. Then only we can apply the remaining De Morgan's or distributive law. So our first aim to be changed this tends to into cup. So while changing that, as per its rule, the first term will get a negation. Already a negation is there. So now as per the tends to formation into cup, this negation is again applied with another negation and get cancelled. So the first bracket will be P cup Q. Here this is changed into cup. Second bracket as such cap. For this again tends to is changed into cup. Only the first term will have the negation term. Already in this previous equation we are having the second part a negation. That will be as such. So now what is the next part? First two brackets, there is no need of any change at present. So the second two brackets, negation is present in common. We are going to apply the De Morgan's law. So negation is applied inside means in that bracket cap will be changed into cup. Similarly for the second bracket. Now we are going to pair these elements. So how we are going to pair? Applying the distributive law. P cup Q cup P, because for CNF cap should be the common symbol. So we are pairing all the cup terms in single bracket. So P cup Q cup P is paired. Then cap, the same two terms is joined with Q. So what you will get? P cup Q cup Q. So this we got in the first two brackets. Next we are going to pair the other two. So what you will get? Negation P cup, negation Q cup, negation P. So all the cup terms are joined. Then cap will come outside. Then what about the next? Negation P cup, negation Q cup, negation Q. So those two representations are given in the other two brackets. So finally, on checking the last line, all the bracket values are with cup, that is in the disjunction form or otherwise called as sum, and they are connected in common by using the symbol cap, which is called as the product. So this is called as the product of sum, which is known as the CNF format. So based on the DNF and CNF, a few questions are here for your practice. Please go through with those problems. Thank you for watching. The next video is on principal disjunctive normal forms. Thank you all.